Okay, this is the fourth and final part of significant figures and scientific notation. This one's going to be a summary of everything we've talked about in the videos. Okay, if we look at the number we got at the top there, it is 123,400. If we start, the decimal point is there, remember, on these numbers. So it's 1, 2, 3, 4, 5. 5 moves gets us 1.234, and that's why we got these 5 moves, gave us the 5 there. And so now we have it in scientific notation, and this part we call our coefficient. And this part we're going to call the magnitude or size of the number. And remembering these two zeros, because they're not between any other numbers, they are just placeholders, so we ignore them. And it was just these 4 numbers here are the sig figs. So this number has 4 significant figures, 4 sig figs. And we do all this sort of thing. So a rule is that the coefficient can only be in that sort of format. So we can only have here, we can only have 1 digit before the decimal, and then the rest has to be followed on from that. Okay, and then if we look at the magnitudes, let's look at the magnitude. So that magnitude, if it's positive magnitude, this is a positive 5 here on the power, then we know the number must be greater than 1. And if it was negative, then it must be much less than 1, okay? And if we were to type this into the calculator, so if we're going to go into the calculator, so into calculator, we would type 1.234 times 10, and then we use the hat 5, but the calculator might spit it out looking a bit different. Let's use this color. So out of calculator, we would end up, it might say something like 1.234 E10 plus 5, and that plus is just telling us positive. So if we're looking at all that, that's how we look at the scientific notation and how to put it in and out of the calculator. And that's how you can just simply add, subtract, multiply, or divide. Just remember, with the dividing and subtracting, you've got to make sure you're putting in your brackets. So doesn't matter the brackets for anything else, but we'll just show that on the next slide. So if we had 1.234 times 10 to the 5, and then we multiplied that by 6.78 times 10 to the negative 9, we'd put that into our calculator, and we'd say 1.234 times 10 hat 5 times 6.78 times 10 hat neg 9, and your answer would be, on your calculator, 8.36652, and then E neg 4. And we've got to be careful here, because remember, this one's got 4 sig figs, and this one's got 3 sig figs. So as they always like to do in exams, they got to cut it off at 3 sig figs. So 8, 3, 6, cut off, have a look over the line. 0 to 4, stay on the floor. Looks like we're climbing the vine. So our final answer, when we write it down, is 8.37 times 10 to the neg 4. Okay, now we can look at the dividing. So if we did 1.234 times 10 to the 5 divided by 6.78 times 10 to the neg 9, in our calculator, we'd have to type in brackets 1.234 times 10 hat 5, close your brackets, divided by, open your brackets again, 6.78 times 10 hat neg 9, close brackets. Now, you're dividing by a very small number. That means you're actually going to get a very big number. And so if you hit the calculator, you'll get 1.820589997E plus 13. And that kind of makes sense because 5 and 9, that makes 14. So you've got 13 here. So it's probably just a little readjustment there, but that sounds right. Okay, so again, we've got to go to 3 sig figs because that's 4, that's got 3, so we can't be more than that for our answer. So 182, that's 3, cut it off, look over the fence, 0 to 4, stay on the floor. We're going to stay on the floor. 1.82 times 10 to the power of 13. That is actually a positive 13. Okay, that's a summary of multiplying and dividing. Okay, let's try just the last part on adding and subtracting summary. So 1.234 times 10 to the 5 plus 6.78 times 10 to the neg 9. Again, on your calculator, no big problems here because it knows to do multiplying before dividing. So you don't need any brackets. Sometimes you like to put them in there just to help see what you're doing. And funnily enough, your calculator will tell you this. That's what mine did. And I'm like, hang on a minute, what happened to all the 6.78 stuff? Well, that's times 10 to the neg 9. There's a order of magnitude difference of 14. That's 10 to the power 14. That's a big number, a difference. So it says, that 6.78 is just nothing. It's like a fly landing on the back of an elephant. It's not going to make the difference to the actual total number. But the 6.78 does affect the significant figures. So we're going to go 3 significant figures, just 1, 2, 3. Cross it off. Look over the fence. Looks like we're staying where we are. So we could write it in normal numbers as 1, 2, 3. And then that becomes, they all become placeholders, yes? So 1, 2, 3, or 1.23 times 10 to the 5. So the only effect was we just lost a significant figure because there'd have to be all these zeros before we even got to the 6, 7, 8. Let's try subtracting. So 1.234 times 10 to the 5 minus 6.78 times 10 to the neg 9. I think we can start to see that probably not going to make a huge difference again. But if we just show you what that means when you type it on the calculator. So it's 1.234 times 10 hat 5. You've got to put these in brackets. Okay. For the subtraction and division, you need the brackets. And that's going to equal the same number we had before, 1.23400, because that fly has now left the elephant and it still didn't make any difference to the weight. So 1.23000, exactly as above, or in scientific notation, 1.23 times 10 to the 5. 14 orders of magnitude difference. That's a big difference. That's a summary of everything we've learned about significant figures and scientific notation. And you can start to see why scientific notation, when you're talking about really big things and really small things, and when you're talking about significant figures, scientific notation actually is the most helpful and the best way.